If we multiply the matrix 1, 0, 0, 1 by the column vector 3.72, negative 9.48, and as usual, you should do that before you look at the answer and listen to my explanation if you haven't already done it. But people in class had very little trouble getting this to work out. Very straightforward calculation, but let's go through it. You multiply the first row by the column, you multiply the second row by the column. When you multiply the first row by the column, you're going to multiply 1 by 3.72 and 0 by negative 9.48. And your result then is going to be 3.72 plus 0, or just 3.72. So the 1, 0 picks out the first number in the column, and that's what you're going to get in the first row. Now, the 0, 1 multiplied by the column, well, the 0 here is going to multiply the 3.72, giving you 0. The 1 is going to multiply the negative 9.48. So you're going to get 0 minus 9.48, or negative 9.48. That isn't written real well. We ran out of board space, and the decimal still doesn't want to show. Okay, and I'm not sure we got a good picture of that decimal either. Okay, so we see that the result is the same as the column vector that we multiplied by. In other words, this matrix just gave us back the same thing that we started with. The result is the same as the vector we multiplied by the matrix. Okay, well, and it's clear how that happened. Having the 1, 0 here is going to pick the first number out of the column. If that's our first row, then the first number here is going to be our first row number. And then similarly, the second row, the 1 in this column is going to, or the 1 in this position, the second position in the row, is going to pick out the second number in the column, and going to repeat that in the product matrix. Well, let's now do the matrix that we see here. We have 1s on the diagonal. We have a main diagonal of the matrix here. We have 1s on the main diagonal and 0s every place else. And that is going to do something very similar to what we did here. The 1, 0, 0 multiplied by P, Q, R is going to give us P, and 0 for Q and 0 for R. So we're just going to have P in the first row of our product matrix. The 1 in the second position in our second row is going to multiply the Q, and we can see that multiplying the column by the 0, 1, 0 is just going to give us Q. And then multiplying the column by 0, 0, 1, we're going to get 0 times this, 0 times this, 1 times this. That's just going to give us R. So again, the 1, 0, 0 row picks out the first number in the column vector. The 0, 1, 0 picks out the second quantity in the column vector. And 0, 0, 1 picks out the third. And the result is that our product is equal to the vector we multiplied by this matrix. Now, an identity in algebra, in arithmetic, is something that gives us back the thing that we're acting on. So, for example, the additive identity is 0. If you add 0 to any number, you get that number. The multiplicative identity is 1. If you multiply 1 by any number, you get that number. These are identity matrices. If you multiply this matrix by any column vector with 2 rows, you're going to get the same thing. If you multiply this matrix by any vector with 3 numbers or 3 quantities in a column, you're going to get that same thing back. So we call these identity matrices.